So we'll start. So in the last class, we discussed a concept named as Biot-Savart law, right? So what does Biot-Savart law state? It is mainly used to find the magnetic field due to a small current carrying element at some point P, right? So how is the formula defined? It is like this. The value of dP, that is the value of the magnetic field produced due to the small current carrying element, is directly proportional to the current that is flowing through it. It is directly proportional to the length of the current carrying element. It is inversely proportional to the square of the distance of separation between the current carrying element and the point P, right? And it is directly proportional to the sine of the angle between the current carrying element and the radial vector. And we did a problem also based on this. So there are two forms in which I explained it. One is in the scalar form. So scalar form, how do you write it? You write it as dB is equal to mu naught ideal sine theta divided by 4 pi r square, right? Where mu naught by 4 pi is equal to 10 power minus 7. The unit is Tesla meter per ampere. If at all you have not made any note it down. So mu naught by 4 pi is 10 power minus 7 Tesla meter per ampere. If the same thing is written in vector form, we write it as mu naught divided by 4 pi into ideal vector cross r vector divided by r cube. And I also stressed on the point that when you write it in the scalar form, the denominator will be r square. When you write it in the vector form, the denominator will be r cube. So please be careful about it. Then we saw right hand thumb rule. So why is it is used to find the direction of the magnetic field due to any current carrying conductor. Okay. So there are different rules also you'll be learning, like Fleming's left hand rule, right hand rule, and all. You should not get confused between all these things. Remember that right hand thumb rule is used to find the direction of magnetic field due to a current carrying conductor. Means if you know the direction flowing through a conductor, yes, indirectly you know the value of, indirectly you know how to find the direction of magnetic field as well. Okay. Then I explained the concept of cross product, and we did one problem also. Now what we will do in this class is we will see the applications of Biot-Savart law. So the topic is going to be applications of Biot-Savart law. So what we will do here is we will calculate the value of magnetic field due to a straight current carrying conductor. I'm repeating it. Magnetic field. The first application is magnetic field due to a straight current carrying conductor. First we will see for finite length, and the second case we will see for infinite length. Okay, let's start. Just give me a second. So start writing. Let us consider, so I'm going to see for a finite length. So let's say you have a current carrying conductor which is of a finite length, and the current across the conductor, let's say it is flowing from the point X to point Y in the upward direction. Let's say there is the direction of current. Okay. Now let us consider a point P which is at a distance A from it. Let us consider the point P which is at a distance A from it. Okay, which is, when I say distance between a point and a line, it has to be the perpendicular distance, right? So let's say there is a distance. Now we are going to calculate the field at this point P, the magnetic field at point P, due to the whole current carrying conductor. Okay, so let's see how to start this. Now what I'm going to do is I'm going to take this point as the initial point. I mean, since we are taking the distance from, let's say, point Q. So from this point, what I will do is I will consider a small element dl at a distance L from it. Okay. So observe carefully. We are going to follow calculus method. So if there is any doubt, please let me know. So at a distance L from it, let us say there is a small element dl that is present, right? So the current is flowing in the upward direction. I mentioned it clearly in the previous class, saying that Biot-Savart law is applicable only for small current carrying elements. So you can always apply that formula only if you have a current carrying element in your hand. So from this current carrying element to the point P, let's say this distance is R. Okay, then this is going to be R vector. Okay, let's say this R vector is making an angle theta here. Okay, then what is going to be the formula for the magnetic field due to the small current carrying element? So dB will be equal to, I'll write the steps, magnetic field due to the current carrying element dl at point P is dB is equal to mu naught divided by 4 pi into ideal sin theta the whole divided by r square. So let this be equation number 1. Okay. Now what I'm going to do is, I will take another angle phi here. I'm taking another angle phi. So what do you think is the relation between theta and phi? Can someone tell me? So how are theta and phi related? That's it. So phi is equal to 90 minus theta, right? So we can say theta is equal to 90 minus phi. I'll take this as 2. Using 2 in 1, what is that we get? We get dB is equal to mu naught divided by 4 pi into ideal sine of 90 minus pi the whole divided by r square. So this will be equal to mu naught divided by 4 pi into ideal, sine 90 minus pi is going to be cos pi divided by r square. This is what is the value of dB. Okay. So you would have learned by now, if at all you have a differential coefficient, if at all you have something like dx, how can I get x from it? Anyone? If I have a differential coefficient dx in my hand, how do I get the value of x? So what mathematical operation are we supposed to do?
Integration from 0 to x.
Okay, integration from 0 to x, that's a good point. So you will get it as x, right? So one thing is clear, if the differential coefficient has to get cancelled, then we need to do the process of integration. Okay, one important point I want to stress about integration is, for example, I'll ask you 2 questions, okay? Tell me one thing, tell me the answer. I'll make it simple. I'll give you a formula. You would have learned this formula. Integral of x power n dx is equal to x power n plus 1 divided by n plus 1. Now, you are going to use the same logic. Okay, you are going to use the same logic, and you are going to tell me what is the value of integral of x power 5 dx and integral of x power 6 d theta. So what is the answer for the first one? Anyone? Anybody who can tell me the answer? X power 6 divided by 6. What about this one?
Power 6.
Sorry?
X power 6 theta.
divided by 6.
X power 6
Theta.
theta. So you're able to understand. Very good. Who's the? Who told no?
Myself, sir.
No, I want to know the name. I'm not used to the voice.
Harini, sir.
Harini? Harini. Very good. So the important point to be noted here is, when you do the integration of the variable with respect to x, then you get it as x power 6 by 6. Whereas if you do it with respect to, if you're doing the integration of x power 6 with respect to some other variable, then even if it is x, that is going to be treated as a constant with respect to the variable. Maybe if the question would have been theta power 6 d theta, then the answer would have been theta power 7 by 7. I hope you're able to differentiate this factor. So the reason why I'm stressing on this point is, whenever you need to do integration, there needs to be only one differential coefficient. For example, if I ask you a question like what is integral of x power 5, the question is meaningless. You should ask me x power 5 with respect to what? Okay, you always need this differential coefficient dx or d theta or whatever it is to exist there. If you look at this question, no, there is a variable dl. Now let's look at the constants. So dl is a variable, cos phi is a variable, and r is a variable. Why I say variables is because this L is a point, this L is a distance which I have chosen. It is up to me. Might be if I give you the same option, you would have taken this L in the above part, right? It is not in our hands, right? It is going to be a variable. Similarly, depending on the place where you take this dl, the value of r keeps changing. If I, for example, if I take the dl here, if I say this is r, if I take the same dl here, might be this is r to some other distance. So r is a variable from point to point. As r is also changing, the angle between these two lines also keeps changing. So what is the only constant that you have in this question? That is a. So a is a constant except a, l, r and phi. All the three are variables. Okay. And when you need to do the integration, you cannot have three variables integrated with respect to something else. Everything needs to be converted to one particular form. So what I'm trying to stress here is, with this particular step, physics part is over. There is nothing. Physics has nothing to do with this. For you to find the total magnetic field, you need to do the integration. But integration, how are you going to do is the question. Okay. So for that, what we are supposed to do is, observe what I'm doing. I'm going to use a method called as substitution method. If at all you have learned this in differentiation, you will understand. So there is a method called as substitution. So I'm drawing a free body diagram of this part alone, of this triangular part. So if I take this point P here, if I take this distance to be R, if this distance is A, and this is going to be L, okay, then I'm going to take this angle as phi. I hope it is clear till this step. So let me join this. So it is going to be phi, it is PQ, and let me call this point as M. Okay, then what is going to be the value of cos phi? If I ask you what is cos phi is going to be the adjacent divided by r, the hypotenuse, right? From this, what I can say is r is equal to a secant phi. Can I say it like this? So r is equal to a secant phi. So by doing this, what advantage I have is, instead of r, wherever I see r in this expression, I can replace it with secant phi. And remember, a is a constant, I have told you, because that perpendicular distance is going to be a constant. Similarly, if I take the value of L divided by A, then what is it going to give us? It is going to give us tan phi. Observe. With respect to phi, L is a variable. Sorry, L is the opposite and A is the adjacent. So L is equal to this thing. So L is equal to A tan phi. Right? So I hope you are able to understand till this step. Now what I will do is, I will take these two as equation number 3. Now I am writing the expression again. Observe. We know that dV is equal to mu naught divided by 4 pi into I into dl sin theta, sin phi, right? Sorry, cos ideal cos phi the whole divided by r square. Now I am going to use these values here, but the point here is, see, when I substitute it, dV is equal to mu naught by 4 pi, I is I only, let dl be here, cos phi. In the place of r, I can write it as a secant phi. So I will write it as a secant phi the whole square. But the question is, I don't have L here, rather I have dl. So what am I supposed to do? So what am I supposed to do to this thing? If I have x, if I need dx, what do I need to do? Anybody?
Differentiate, sir.
Obviously. So you need to differentiate on both sides. Differentiate on both sides. So when I say differentiate on both sides, you need to ask me with respect to what again? Differentiate on both sides with respect to the variable, with respect to phi. Then what I will get here is dl divided by d phi is equal to a into derivative of secant phi is, sorry, derivative of tan phi is secant square phi, which implies dl will be equal to a secant square phi d phi. Okay, so here if I leave it as dl, now see what I'm going to do is I'm going to write it as mu naught divided by 4 pi into I into, in the place of dl I will write it as a secant square phi d phi into cos phi the whole divided by a square secant square phi. Okay, now what will get cancelled? Secant square phi and secant square phi is gone, a and a is gone. So you will have mu naught I into mu naught I divided by 4 pi a into cos phi d phi, which is dv. Till this step, is there anyone having a doubt? Till this step, is there anyone having a doubt? So I hope it is.
No, sir. It's clear.
No. Clear. Okay, then it's good. Let me check. Okay. Now what we need to do is, if you observe the difference between this expression, this is what we have converted into this form. You had L, phi and R, three variables is converted to one variable, and you have the privilege to integrate that with the same variable. Okay, whatever is inside the differential coefficient will tell you with what you can integrate it. Now, if I take the integral on both the sides, then integral of dv will become b, which will be equal to mu naught I divided by 4 pi a into integral of cos phi d phi. This is what happens. Okay, now we need to understand what are the limits that we are supposed to take. So for that, I will go back to the first diagram again. Observe. So you have this thing, right? So in this part, I'm doing a small construction. Observe. So the construction I'm trying to do here is I'm joining this point. I'm joining this point. So by doing so, what I'm doing is from P to X when I join, I'm covering the lowermost point of the infinite length rod. Similarly, when I join from P to Y, it's not infinite, sorry, it's finite length rod. P to Y, I'm covering the end, the topmost end. So this phi is a variable now. Variable means it is changing from one place to another. So if I take this angle to be phi 1, then this angle, if I take it as phi 2, then the integration that we are going to do is with respect to, so the integration that we can do will be from minus phi 1 to phi 2. If I do that, when the value of phi is equal to phi 1, it is at this point. When the value of phi is equal to phi 2, it is at this point. So I have covered the entire length of the rod. If that is the case, then you will get sum of all the magnetic fields produced by all such elements which are present on this particular conductor. Okay, if that is the case, now observe minus phi 1 to minus phi 2, then this can be written as mu naught I divided by 4 pi a into, what is the integral of cos phi? It is sin phi from where to where? Minus phi 1 to phi 2. Okay, so this will be equal to mu naught I divided by 4 pi a into sin of phi 2 plus sin of phi 1. The reason I wrote plus sin of phi 1 is you will get minus sin of minus phi 1. Sin of minus theta is minus sin theta. So that is why that plus came out. So B will be equal to this value. So this is going to be the final expression. Okay. So B will be equal to mu naught I divided by 4 pi a into sin plus phi 2. I hope this is clear. So this is going to be the formula. If you're clear with this, I'll just show you the special cases. Then I'll give you some time to write down.
Sir, can you just repeat once how we got phi 1 to phi 2?
It is because, see, here observe the angle.
So the voice is breaking actually.
I didn't speak 1 minute. I'm just marking it again. Yeah. So see this. This phi is the variable. Am I right? Is that point clear?
Yes, sir.
So if I need to be here, what should be the value of phi with respect to my horizontal line, with respect to PQ? So phi is a line angle made by PQ with respect to the radial vector, that is R vector, right? So the maximum value of phi that is possible in the downward direction is this thing. If I call that as phi 1, the least value is the downward side. The maximum value that is possible in the clockwise side is going to be in this direction that I'm taking as phi 2. Since this is going to be in this direction, I'm putting an arrow mark like this. Since this is in the downward direction, I'm putting an arrow mark like this. So with respect to this case, what I'm doing is, it is neither x-axis nor y-axis. With respect to this case, I'm taking this direction to be negative and this direction to be positive. And that is the reason why, if you observe phi 1, it is going in the negative direction. The reason why I took it as minus phi 1, and phi 2 is going in the positive direction. That's why I took it as plus phi 2.
Yes, sir. Okay. So
Clear? Yeah. So now we'll do one thing. Just give me a minute. Yeah. So this concept is clear, right? So we'll go to the special cases. Just a minute. Yeah. So we'll see the special case. That is when the conductor is of infinite length. So when the conductor is of infinite length, there are two possibilities. One is, observe, I can take a point P at one of the ends of the conductors. Okay, if I take the point P, then this distance will be A. Now, let's say the current is flowing in the upward direction. Then what is going to be the magnetic field in this particular case? The formula is still mu naught I divided by 4 pi A into sine phi 1 plus sine phi 2. So this is going to be the value of the magnetic field. Now, what is going to be the value of phi 1 and phi 2? I will draw a rough diagram here so that you can visualize and tell me what is going to be the value. So when I take it like this, according to the derivation, this is phi 1 and this is phi 2. This is a point P. This distance was A. Current was flowing in the upward direction. Okay. In this case, if you do a comparative study, what is going to be the value of phi 1 and phi 2? Anyone?
Phi 1 is 90.
Phi 1 is going to be 90. Good.
Phi 2 is 0.
Very good. So phi 2 will be 0 because when this point is coming here, no, it is making no angle here. right? Whereas when if it is an infinite length, this point and this point will meet only at infinity. Means they both will be set of parallel lengths. So what is happening to the value of phi 1? The phi 1 is getting opened in such a way that it becomes like this. So phi 1 will be 90 degrees. So phi 1 is 90 and phi 2 is 0. If you substitute these two values in this expression, then what is going to be the value of b? It is mu naught I divided by 4 pi a into sine 90 is going to be 1 plus 0. So what is the answer? B is equal to mu naught I divided by 4 pi a, provided you have taken the point P at one of the ends of the infinite length conductor. So this is the value of magnetic field when the point is considered at one of the ends of the infinite length conductor. Okay. It's in a similar way, if you consider the point P, in a similar way, if you consider the point P to be exactly at the center, then what would have happened? If you would have considered exactly at the center, what would have happened?
Both will be 90 degrees.
That's it. So phi 1 will be 90, and phi 2 will
Phi
also be
2
90.
will also-
Very good. Very good. So phi 2 will also be 90. Then the value of B will be equal to mu naught I divided by 4 pi A. Remember this formula, sine phi 1 plus sine phi 2. Sine 90 plus sine 90 is going to be 2. So it will be mu naught I divided by 2 pi into A. That is going to be the value of B. Is it clear? So this formula is what is used throughout this chapter. In most of the places, you will be using this formula. Am I clear with this? Right? So if you're clear, I'll proceed to the next concept. You need not worry about copying this. I will share these notes with you, whatever I've written here. You can make a note after the class. Done? Yes or no? Okay. Okay, we'll do one thing. I'll give you some example problems and let's try to solve them. So draw them. So example problem based on magnetic field of a straight wire of infinite, may not be infinite, straight wire concept. It can be of finite or infinite length, that varies from problem to problem. Now what I'll do is, see, observe. The first question is, let's say there are two parallel wires of infinite length carrying the same currents in the same direction. Now what you need to do is, you need to calculate the net magnetic field at point P, Q and R. Let's say the distance of separation between these 2 points is D, and if I take this distance to be A, let me say this distance is B, and let's say this distance is C. Okay. So these are all the cases. You have to find the magnetic field due to the system at point P, Q and R along with their direction. Second, there is a square which is formed out of 4 finite length wires of same length where the current is flowing in a cyclic pattern. Let's say current I is flowing through a square of side A. We need to calculate the magnetic field due to the system at point P, which is the point of intersection of the diagonals. So how to proceed? Okay. So I'm going to give you the formula alone. What formula you can use is, so write down the formula alone. B is equal to mu naught I divided by 4 pi A into sine of phi 1 plus sine of phi 2. This is one formula. B is equal to mu naught I divided by 4 pi A. This is when point P is at one end, and B is equal to mu naught I divided by 2 pi A when point is at the center. Point is at center. So these are all the formulae. Now how you are going to apply, you have to think. So just copy these diagrams first. So if you're done, let me know in the chat box. Done. Okay, those who are done, you can start solving. Just write on your own. Done. Huh. Can someone tell me how to solve the first one? I'll give you exactly 5 minutes time. So when you're trying, try it with the direction. Try it with the directions. One more minute. Done. Anyone with the answer? Who can try at least? Who can tell me that these are the steps to be followed? Who can at least make an attempt so that I write it? So if I take the infinite length conductor and if this distance is taken as A and if the distance of separation between them is D, I think this point is B, right? This point is B and this distance is C. So let me take this point as A, B and C. What is going to be the value of magnetic field at point A according to the formula? Now, how many conductors do I have in my hand? I have two conductors, 1 and 2. So, magnetic field at point A due to first conductor, what is it? Hi guys there. Seconds mu by 2 pi A. I have to check something, Sachin. When we do it, well, let's verify it. So, who can tell me? You have the formula in front of you. So, magnetic field due to the first conductor at point A is equal to mu naught I divided by 2 pi A. Okay, so what is the direction of it? If you're not going to speak, I'll just write it and go. I'll not be concerned whether you understood or not. I'll not ask these many times. Anti-clockwise is not the case.
Minus I cap.
Minus?
I cap.
It is not minus I cap. Just try, no? See, how do you find the direction of B? Yesterday I told you, no? When you use vectors, you have I into dl vector cross r vector. So dl will take the direction of current and r vector will take the direction from the current carrying conductor to the point where you are trying to calculate the field. So if that is the case, the first current carrying conductor is like this, the point A is like this, so this distance is going to be A. So what should I write in the place of dl? What is the direction of dl?
Cap.
Sorry?
J, sir.
Good, yeah, it is j cap. Good. Cross,
Cap.
it is going to be I cap. So what is j cross I?
K cap.
No.
Minus K
Minus
cap.
It is
K
minus.
cap.
It is minus. So what you understand from this? So due to the first current carrying conductor, the field at point A is into the plane. So at this point, it is into the plane. So do the same thing by applying the right hand thumb rule also. Everybody, what you can do is, since you would have drawn it in your notes, I'll suggest you put your palm on the paper. Okay, put your palm on the paper and extend the thumb in the direction of the current in the first conductor. You put the palm of your right hand on the paper. Okay, the palm should be facing down, the knuckle should be facing you. So when the palm is facing you, extend the thumb of your right hand in the direction of current and start curling the finger of the right hand. In which direction is it going? Is it going into the paper or out of the paper?
Out of the paper.
No. For the first conductor.
Into.
It will go into the paper. It will go into the paper. That is why you have this minus K cap. Okay. So will be not direction of. Okay. Similarly, what is going to be the value of magnetic field at point A due to the second conductor? Anybody? So I think the current is taken the same. Both are same currents. Same formula again. Mu naught I divided. Should I write 4 pi a or 2 pi a?
2 pi A.
It is again 2 pi a. So mu naught I divided by 2 pi a. Now what is going to be the direction? So again, how to find the direction is observe it carefully. Yes, somebody told the answer.
K cap.
K cap is right, but how did he get it?
I cross J.
Okay. So it is going to be dl vector cross r vector. So what is dl vector? So with respect for the second conductor, what is the direction of current? Upward, right? It is going to be j cap cross. With respect to this, what is this direction?
Minus I cap.
Minus I cap. Right. So j cross minus I means it is going to be minus k cap with a minus sign outside. It is going to be k cap. So it will be in the outward direction. So it will be in the outward direction. But what should I write here? Mu naught I divided by, I made a mistake here in this equation. Can someone correct it? Sorry, somebody told. It is d minus a. Very good. So mu naught I divided by 2 pi into d minus a, and what is the direction? It is going to be plus k cap. So what is going to be the total magnetic field at point A? It is going to be equal to, if I call this as b1 vector, if I call this as b2 vector, it will be b1 vector plus b2 vector. I am doing the vector sum. So b1 vector is equal to mu naught I divided by 2 pi a in the direction of minus k cap, plus this is going to be mu naught I divided by 2 pi into d minus a in the direction of plus k cap. So this is going to be the resultant for both. I hope it is clear. So I hope it is clear, everyone. Using the same logic, can you find the magnetic field at point B? Using the same logic, can you tell me what is going to be the magnetic field at point B? So the conductor, the first conductor is here, the point B is here. This is B. The second conductor is here, and the distance of separation between them is D. Then how do I find the value at point B? The values of currents are the same. I hope you would have understood the logic of how to approach. Again, I'll take this as the first conductor, this as the second conductor. What is the magnetic field due to the first conductor at point B? Point B. Mu naught I by 2 pi
B.
2 pi B. Direction?
K cap.
Are you
Minus
sure? It is K cap only. Those. So it is K cap because remember, if you take a straight current carrying conductor, it may not be straight current carrying conductor, for that matter any conductor. If on the right of it, if the field is into the plane, on the left of it will be out of the plane. So if you observe, point A was on the right hand side. No. So with respect to this current carrying conductor, since the field was inside, on the left hand side it should be out of the plane. So k cap is right. So this is B1 vector. Similarly, who can tell me what is B2 vector? It is mu naught I divided by
2 pi b plus d.
that's it. B plus D into direction. Apply right hand thumb rule. Base is going to be k cap. So what is going to be the net value of magnetic field at that point? It will be B1 vector plus B2 vector. That is going to be mu naught I divided by 2 pi into 1 by B plus 1 by B plus D 1 by B plus 1 by B plus D k cap. So this is going to be the final result. Okay, with the similar way, I'm leaving the point C to you people. You can do it. Okay. Next, we will do the second problem. So the second problem is like this. If I take the current carrying conductor to be in the form of a square of side A.
Sir,
Yeah, Harini, tell me.
sir, can you repeat how to find the direction of magnetic field using right hand thumb rule again?
Using, I will switch on my video itself, that's better. So you're able to see me, right?
Yes,
What I'm
sir.
saying is, so if this is the conductor, if this is the conductor, okay, there is a conductor across which the current is flowing.
Yes,
For
sir.
example, let's say there is the first conductor. The point A was on the right of the first. See, with respect to me, I'm not sure how it is appearing on that side. With respect to me, there is the right. With respect to me, there is the left for the first conductor. So what does right hand thumb rule state? Place the thumb of your right hand in the direction of current and curl the fingers of your right hand. So when I'm curling, see what I'm going to do. When I'm curling the fingers, it is going into the plane. On the right of it, it is going into the plane. So into the plane is where is it? It is at point A. So when I curl it in this way, it is coming out of the plane at point B. So I hope you're able to visualize it. So into the plane at point A, out of the plane at point B. So that is what I'm trying to say with respect to any conductor. If one side, if the field is into the plane, the opposite side it will be out of the plane, unlike your electric field. I hope it is clear.
Yes, sir. Yes, sir.
Good. Now we will see. If I take this point to be P, okay, then it is a finite length conductor because it is going to have a finite size. Right. We know that the angles, we know that the diagonals for a square meet at 90 degrees. Right. Then what will this perpendicular distance be? It is going to be A by 2. Accepted. Now, what is this angle and this angle? Can someone tell me?
45 degrees.
Obviously 45 degrees, right? So 45 degrees and 45 degrees because it's going to form an isosceles triangle. Now the question is, for a finite length conductor, we will write down the formula again. So what are we trying to say? The finite length conductor is B is equal to mu naught I divided by 4 pi A into sine phi 1 plus sine phi 2. See, it is not only about the formula, you need to be very keen on where should this phi 1 and phi 2 be taken. If suppose in the question they have given you these values and you take that as phi 1 and phi 2 and substitute, your answer will be wrong. Because while deriving, we didn't take the phi 1 and phi 2 to be these angles. These are not phi 1 and phi 2. This is phi 1 and phi 2. This is phi 1, this is phi 2. This is right. Okay. In a similar way, so phi 1 and phi 2 are near the point where the field is to be calculated. They are not close to the conductor. So in that case, what should I take the value of this conductor as? So if I take this as first conductor, second conductor, third conductor, and fourth conductor, what is the magnetic field due to the first conductor at point P? It is going to be mu naught I divided by the same formula 4 pi A into sine of
45.
very good sine of 45 degrees plus
Sine 45.
Sine 45 degree. Direction. Just now I showed you. So what is the direction of magnetic field at point P due to this conductor?
Minus k cap.
Very good. It is minus k cap. So it is into the plane. It is going to be into the plane. So B1 vector. Now what about B2 vector? Sanjana, can you tell me what is the value of B2 vector? It is mu naught I by 4 pi a. Proceed.
Sine 45.
It is going to be still sine 45 only. Good. Sine 45 plus sine 45.
Sine 45.
What is the direction? Can you use your right hand thumb rule and tell me what is the direction?
Out of the plane.
Just check it 1 second. Tilt your book and see, no? You'll get a clarity.
Inside the plane, sir.
It is into the plane only. It is into the plane. See, I know you will get confused with this. What happens is, observe. I will suggest you to remember this dl vector cross r vector. Okay, this is going to give you the direction of magnetic field because vectors will never confuse you. You have that circle and all those concepts, so it will be easy for you to recollect it. So remember it as dl cross r. For the second conductor, what is the direction of dl? Dl means direction of current. Current is in which direction?
I cap.
I cap. Cross r vector means r is the vector from the current carrying conductor to the point P. So direction of r?
Minus J cap.
Very good. So it is minus j cap. So I cross j is how much?
Minus K cap.
I cross j is k. So k with a minus sign is minus k cap. So that is why it is minus k cap. Okay. In a similar way, what will be the value of B3 vector? B3 vector will be the same thing, mu naught I divided by 4 pi a into the same sine 45 plus sine 45. No change in that. But I am more concerned about direction.
K cap.
Is it k cap? Is it because this is having in the direction of minus k cap, this should be in the direction of plus k cap?
Cap, sir.
It is still minus k cap. Let me explain the reason for it. Because I told you only thing to be remembered is dl cross r. So with respect to third conductor, what is the direction of dl? It is minus j cap cross. What is the direction of r vector for this? R vector is in the leftward direction. From the current carrying conductor to the point P.
Minus I cap.
That's it, minus I cap. So minus j into minus I is going to be j cross I. J cross I is again minus k cap. Okay. So this is also minus k cap. Common mistake that happens is just B1 is producing magnetic field should be in opposite direction. Okay. Now similarly, if I do for the fourth conductor, what is the value going to be? B4 vector is equal to mu naught I divided by 4 pi a into sine 45 degrees plus sine 45 degrees. Then what should I write? So again, I will take dl vector cross r vector for your understanding. Fourth conductor, what is the direction of dl?
Minus K.
Minus I cap.
Very good. Minus I cap. R vector?
J cap.
J cap.
Very good. So it is j cap. It is in this direction.
Minus
So this is
K.
j cap.
It's minus
So
K.
I cross j is k. So with a minus sign, minus k cap. So there is going to be minus k cap. So if you observe, all the magnetic fields are in the same direction. So what will happen to the summation? The vector sum will be equal to b1 vector plus b2 vector plus b3 vector plus b4 vector. Right. So what is going to be the value? It is 4 times mu naught I divided by 4 pi a multiplied with sine 45 plus sine 45 is 1 by root 2 plus 1 by root 2. The whole thing multiplied in the direction of minus k cap. So 4 and 4 is going to get cancelled. Mu naught I divided by, it is going to be 2 by root 2, that is root 2. So root 2 mu naught I divided by pi into a in the direction of minus k cap. Yeah, tell me.
So how is the distance from the point P and the conductor A? Shouldn't it be A by 2?
Yeah, I'm sorry about it. Yeah, that's right. I should have written a by 2. Thank you. So it should be a by 2. So then this will also be a by 2. Then this 2 will go up, you will get it as 2 root 2 times mu naught I divided by pi a in the direction of minus kk. As simple as that. Clear? So I hope everyone is clear with this. Let me just check the answer once. No more mistakes, right? 1 by root 2 plus 1 by root 2 is 2 divided by root 2. 2 divided by root 2 is root 2. This 2 will go up 2 mu naught. 2 root 2 mu naught I divided by. That's right. So this is going to be the final answer. See, you need to have a clarity of how to find the direction using right hand thumb rule as well as using the vector concepts. Okay, so I want you to practice these things before the next class. I'll just give you a few problems for you to practice. So take down these problems as as homework. So you consider a rectangle of side A and B where the current is flowing in the counterclockwise direction. Of magnitude I, you need to find the magnetic field at point P is equal to what? Second, let us take a triangle, an equilateral triangle, across which the current is flowing in the clockwise direction and the side of the equilateral triangle is point A, You need to find the magnetic field at the centroid. When I say magnetic field, you need to find them along with the direction. Okay, then what can we think of? Okay, you will take a hexagon of side A. The current is flowing in the direction like this. You need to find the magnetic field at the center of it. These three are the homework parts. This notes I will be sharing it with you after the class is over. Okay, after this class I will be sharing it with you. If there is any doubt, let me know. If there is any doubt, let me know, or else we can wind this class.